A very warm welcome to this media background briefing on the James Webb Space Telescope. My name is Ninja Menning. I'm the head of the newsroom and media relations at ESA, and I am here today with Günther Hasinger, ESA Director of Science, Thomas Zurbuchen, Associate Administrator Science Mission Directorate from NASA, Gilles Leclerc, CSA Director General from Space Exploration, and Antonella Nota, ESA Web Project Scientists, and Daniel de Chambure, ESA Acting Head Ariane 5 Adaptations and Future Missions, and last but for sure not least, Beatriz Romero, Web Project Manager from Arianespace. Welcome. And with this, I will give the word directly to Günther Hasinger, ESA Director for Science. Welcome, Günther.
Yes, good afternoon and good morning all around to this James Webb Space Telescope press briefing on behalf of ESA and also on behalf of our partners, NASA and the Canadian Space Agency. James Webb Space Telescope is the largest and most powerful space telescope ever built. It can see further with any higher accuracy that we could imagine. And James Webb is a wonderful time machine. It will actually, like archaeologists, dig deeper and deeper to unravel the history of our universe. James Webb will drill deep holes into the early universe and to show us where we came from. In this picture, you see a comparison of the deepest Hubble images so far on the left side, and then a simulated image of what we expect from James Webb, and you see how powerful and how brilliant it is. The next image shows a side-by-side comparison between Hubble on the upper row and Webb on the lower row of the same patch of the sky. And when you look in detail, then Webb can see much sharper and we get much more information and also many more fainter objects. And some of these fainter objects are really the first light galaxies that we are craving so much to observe. James Webb will be very well embedded in the ESA fleet of cosmic observers, where it will complement our workhorse observatories Hubble, together with NASA and Gaia, as well as the high-energy observatories XMM, Newton, and Integral. And Webb is a wonderful cooperation between the three agencies, if I can have the next slide, please, NASA, ESA, and CSA. And Europe is providing the launch on the Ariane 5 from Kourou, as well as a team of scientists that work hand in hand with the colleagues in Baltimore. And then major contributions to two instruments, NIRSPEC, where ESA has the lead, and then MIRI, where we are in partnership. Webb is happening at a place next to you. All over Europe, we have academic and industry partners that have worked together to make this dream a reality. And with this, I'm happy now to hand over to my colleague, Thomas Zurbuchen, NASA Associate Administrator for the SMT department.
Hey, thank you, Günther. And I just want to tell you how glad I am to be here with you, Günther, and all the other partners who have been a part of building this amazing telescope together. You have just been saying, Günther, of course, we have a long history of working together, and our missions are always stronger when the best minds from around the world work as one, like we are here. I'm so excited for this mission personally, of course. It's a genuine Apollo moment for NASA and the entire world. After decades of building towards this goal, we're going to be able to see the universe just like we've never seen it before. You're going to hear more details about Webb science, just over and above what Günther already did, but I want to give you some information about how Webb fits into the science we're doing at NASA. We have a portfolio over 100 missions in development or in operation. Over 40 of them are focused on the most beautiful planet we have ever observed, the one that is the home for our history and our future, our Earth. The others include missions that study the sun, our solar system and the universe, such as Hubble, you just talked about, Günther, Spitzer, TESS, Transiting Exoplanet Survey Satellite, just to name a few. And Webb will not only complement these missions, but become the center of the entire astrophysics observing program for the next decade or more. It will allow us to observe the universe back in time to 1 to 2% of its age. And it is like looking into a photo album of the universe and seeing images at the very wellspring of that breathtaking cosmic ocean of that we're part of now. We have lots of questions about the origin of galaxies and stars, and Webb can carry the promise to answer them. The possibility of answering such big questions, one of the reasons I'm a scientist, frankly. These civilization scale type of questions, the ones that not only change what we know, but how we think as humans. In addition, one of NASA's key goals is, of course, to search for life in the universe outside of Earth. We are investing billions of dollars for that purpose, sending Perseverance to Mars in preparation of a European collaboration Mars sample return, Clipper to Europa, Dragonfly to Titan. The questions of the origin of life keep us up at night, and it's one that we've carried with us for millennia, and we're starting to answer with the powerful tools of science. Webb has a unique role in this pursuit and will help us look for exoplanets, planets in orbit around other stars. We will not only be able to analyze their orbits, but the chemical composition of their atmospheres. By combining these data and the data from other missions and ground observations as well, we'll be looking to see if these planets might exist in habitable zones of these stars, or even if they show signatures of life. Webb is going to be able to see these planets in also planets in our own solar system with incredible resolution and spectral range, looking at Mars and the bodies all around, including, of course, studying dust storms and water ice variability in Mars and so forth. So Günther mentioned, when we think about how Webb will help us observe the universe, it's helpful to think of it in the context of Hubble, and he did such a good job talking about this. And so for us, as we go beyond Hubble and think of the first galaxies that formed after the Big Bang, we're looking at stars, galaxies in space that we've never seen before, made entirely or primarily out of light elements initially, hydrogen and helium, long before planets, then stars like our sun, or even dust floating in space existed. So we really seek to be surprised. We seek to learn with this amazing telescope. So I just want to tell you how proud I am of this. And you just looked at the picture that our colleague showed of the amazing telescope that's sitting there. I want to tell you, this picture is a few weeks old because it has been folded up, basically almost done. Just in May, Webb opened its iconic primary mirror for the last time while on Earth. This 6.5 meter mirror is made of 18 gold-coated beryllium segments. Once launched, it will be the largest mirror ever deployed in space, and really protected, of course, and kept cool by a 5-layer kite-shaped sun shield the size of a tennis court. For launch, all of these parts will be folded into something small that fits into a 5-meter fairing. Then over the course of 3 to 4 weeks after launch, we'll get to watch about 50 major deployments and 178 release mechanisms unfold the telescope for use. Every one of those deployments need to work for the telescope to function like it's intended. We're going to be holding our breath and biting our nails, and I'm sure Günther with me and all the others, but the risk is worth it. We're pushing the limits of what we're able to build. The cutting edge technologies and the scientific returns are going to be amazing. I can't really wait to find out what we'll learn with this magnificent telescope when it's finally delivering on its promise. Next is Gilles Leclerc, the CSA Director General for Space Exploration. Gilles?
Thank you, Thomas, and thank you, Günther. It's really a pleasure for me to represent the Canadian Space Agency today. And Canada is extremely proud to take part in this great endeavor to launch the most important space observatory of the next decade. This is truly a civilization scale mission. And I must say that CSA's participation in Webb is the largest space science project in the 60-year history of Canada's space program. Exploring the universe is an ambitious venture, and collaboration has proven to be time and time again key to success. Canada is a partner of NASA. We are also a cooperating member of the European Space Agency. International cooperation is vital to our space program here in Canada. The James Webb Space Telescope is the result of close to 25 years of planning and development with our international partners, NASA and ESA. and with our Canadian team members, the National Research Council of Canada, Honeywell Canada, the Université de Montréal, the Canadian Instrument team, and of course, the science team. Thanks to Canadian expertise in astronomy, science, and engineering, we are contributing two important elements of Webb: the fine guidance sensor and the near-infrared imager and slitless spectrograph known as the NIRISS instrument. The fine guidance sensor will be used during all scientific operations, all scientific observations made by Webb. It will latch precisely onto key reference points in deep space to help offset any movement in the telescope and capture clear and detailed images. NIRISS is one of the telescope's 4 scientific instruments. It will be used to demonstrate the composition of exoplanets' atmospheres, observe distant galaxies, and examine faint light sources in the vicinity of bright objects. The Canadian Space Agency will also support Webb science operations with a dedicated team of engineers and scientists. And as we get closer to the launch, and I can't wait, we feel a growing enthusiasm in the community here in Canada for the broad variety of research topics enabled by JWST. We're especially pleased that young Canadian astronomers showed a lot of interest and presented strong research projects during the call for proposals for Webb's first years of operation. With the Webb Space Telescope, we will enter a new chapter in our understanding of the universe and our place in the universe. And this new chapter will open with a new generation of astronomers ready to embark on a journey of discovery. It's an exciting, historic time for astronomy, and Canada is thrilled and proud to be part of the journey. Thank you.
Thank you very much, Gilles. And with this, I would like to give the word to Antonella Nota, who is ESA's Webb project scientist, and who will tell us a bit more about Webb science goals and the instruments that were contributed by Europe. Antonella, the floor is all yours.
Thank you, Nina. It's a pleasure to be here to tell you about the amazing science that Webb will do. At the European Space Agency, we're just thrilled to partner on this magnificent mission together with our colleagues at NASA and the Canadian Space Agency. And I can tell you that the European astronomical community is fully engaged, committed, and ready to go. They've been very successful at getting Webb time in the last round of proposals, and they are very, very eager to get their first data. And the reason we all know, is that Webb will make amazing discoveries in all fields of astrophysics. As Thomas just said, from the early universe to characterizing exoplanet atmospheres, I think we just cannot wait to be surprised. So as you can see in the next slide, Webb is building on what Hubble has been able to do in its 31 splendid years in orbit. So Hubble, in spite of the fact that it's still a relatively small telescope, 2.4 meter mirror, has been able to push the horizon of the observable universe all the way to a few 100 million years from the Big Bang. With a factor of 100 increase in sensitivity, Webb will push way through and will be really able to see how the first galaxies assembled. Exoplanets is another hot topic for Webb. Exoplanets are planets outside our solar system. We know there are many, many of them. And Hubble has pioneered this technique, which is called transit, to basically observe the thin atmospheric layers of this tiny exoplanet as they transit in front of the central star. So you can only imagine, with this 100 times increase in sensitivity, what Webb will be able to do. In the next slide, I want to provide a simple explanation of why Webb will observe in the infrared. So this is a star-forming region, which you all know very well from the Hubble observation. It's the pillars of creation. To the left, you see it in the visible light. That is the light that the human eye can see. So what do we see in this picture? Astronomers do know that there are tons of newborn stars in that region. Why? Because we see massive presence of gas and dust, which is the fuel that makes stars. But we don't see the stars themselves because they are embedded in this very colorful cloud. Now look at the right. This is the image of the same region taken in the near infrared. Yes, because Hubble has some infrared capabilities too. Suddenly, the dust is gone. It's like a veil has lifted, and you can see through the dust, and you can count hundreds, thousands of newborn stars being formed right there. For astronomers, this is data paradise because, and this is close to my heart, you can actually measure every individual star. You can ID each one of them, and you can get a full picture of how this region formed after the molecular cloud, the original molecular cloud collapsed. So as we see in the next slide, Webb will have a powerful complement of instruments that will address all these science themes that we just discussed. Let's not forget that, however, Webb will be a spectroscopic telescope. We know that images of the cosmos are very powerful, very inspiring, but astronomers need to understand what their sources are made of, in addition to looking how they look like. And that's where spectra come in. And to quote a distinguished panelist that we just heard speak a few minutes ago, why we say that an image is worth 1,000 words, a spectra is worth definitely 1,000 images. So the workhorse spectrograph will be NIRSpec. NIRSpec is provided by the European Space Agency and will be a powerful and efficient spectrograph. Will be complemented by MIRI, the mid-infrared instrument provided by ESA and the European Consortium. And then we heard Gilles talking about NIRIS, the Canadian Space Agency. And last but not least, the powerful camera NIRCam provided by University of Arizona and NASA. So we can't wait to see what these instruments will do. And this will be the reward for the thousands of people who have been working on this project for so many years. We really cannot wait.
Thank you, Antonella. Fascinating. Thank you so much. Of course, before we can all enjoy the science from James Webb, we have to bring it into space. And with this, I would like to give the word to Daniel de Chambure and Beatrice Romero from Arianespace, who will tell us a bit more about the launch vehicle, the European spaceport requirements, and of course, the mission and launch campaign preparations. Daniel, I would like to give you the word first.
You're muted.
Now we hear you very well. You're still muted, Daniel.
Okay, it's okay now?
Yes.
Okay, sorry. So thanks very much. After Science Dream, we go to rocket engineering. And Ariane 5 is indeed very proud to launch Webb from French Guiana. It will follow the launch of several prestigious scientific missions of the European Space Agency. First one being XMM Newton, the X-ray observatory, which was launched 20 years ago and which is still in operation. Second one was Rosetta, the comet chaser, which made beautiful science and images of Chury comet. Third one were combined Herschel and Planck infrared and microwave survey satellites, which did observation at the same place as James Webb will do. It is to say, on an halo orbit at the second Lagrange point. And last, Bepi Colombo, which is en route toward its final destination, Mercury, which should be reached in December 2025. Ariane 5 is the Europe workhorse, mainly adapted for geostationary missions, with more than 10 tons payload capacity, which makes it the world leader in its category. Ariane 5 fairing is huge, as it has been reminded by earlier speaker, with a diameter of 5.4 meters and a length of 17 meters. Its size is just able to contain Webb with its equipment, instruments, and folded mirrors. On top of it, we have adapted Ariane even further for Webb to accommodate its delicate and ultra-clean instrument and mirrors. In particular, the venting system of the fairing and the trajectory and control law of the launcher have been optimized to protect Webb in terms of depressurization under the fairing and also thermal heat loads after fairing separation. With respect to cleanliness, a number of precautions have been taken, ranging from extra fairing cleaning, ground launch campaign operation carried out under ultra-clean condition, and a specific upper stage avoidance maneuver, which will be carried out after spacecraft separation. As for all Ariane launches, Ariane will be launched from the Centre Spatial Guyanais, the European spaceport located in French Guiana. The Centre Spatial Guyanais is well adapted for the launch, thanks to its geographical position favorable to launch performance due to the slingshot effect. But it is also a zone free of cyclone and earthquakes. The European spaceport relies on a strong experience of launch teams, which have carried out almost 300 launches over 40 years with Ariane, Vega, and Soyuz. Now, speaking of activities in the European spaceport, I propose to give the floor to Beatriz Romero, my counterpart in Arianespace. We should give you more details on the features of the launch campaign preparation.
Thank you very much, Daniel, and good afternoon to all. So I'm the program director for this mission for Arianespace. Arianespace is the European launch services provider that offers those services for all types of satellites into many different orbits. Since 1980, we have launched more than 800 satellites using this family of launchers that Daniel described before, Ariane, Soyuz, and Vega, from different launch pads, but also, well, the most important is the French Guiana. ESA and NASA have honored us with the launch of James Webb. And for this mission, we will use the heavier rocket of our family, the Ariane 5. And before James Webb, we have planned other 2 Ariane 5 launches, the first one in the second half of July. Regarding the launch campaign, so the James Webb launch campaign has a duration of about 10 weeks. The first 2 will be for the preparation of the facilities, and that will be done in parallel of the shipment of the observatory. It would be long. It's a long trip because for these satellites will be transported from California to French Guiana by boat across the Panama Canal and directly docking in Paracabo Harbor in Kourou, with the city closer to the European spaceport. And then we will have 8 additional weeks for the preparation, the final operations, standalone, fill-in, and the combined operations. The liftoff will occur in the morning between 8:45 and 11 a.m. local time. And then we will have a trajectory profile that is really very similar to the geostationary missions, but of course with a much higher apogee, because we need to inject the observatory directly into the L2 transfer orbit. So the separation of the James Webb Telescope will occur about 27 minutes after the liftoff. And then it will start the journey alone for 4 weeks to achieve the final orbit, this Sun-Earth second Lagrange point. Thank you very much.
Thank you very much, Beatrice. Thanks a lot. And with this, I would open the floor to questions and, of course, also answers from our panelists. If you have not seen it yet, in the chat function, you can raise your interest, indicate your question, or just mention that you have one, and then we will give you the word in a moment. We might not have enough time to answer all the questions, so I will also try to merge some that are similar. And with this, I would like to start with the first question that is from Fulvia Croce from the Global Science magazine. Fulvia, can you hear us? Can you hear us, Fulvia? You should be unmuted now. No, I think Fulvia has. Do you hear us?
Maybe I can read the question that she wrote.
If you want to, Günther.
I believe what she wrote is, how will the data benefit the European scientific community? So, you know, Antonella has already said that European scientists have been very successful. Web data is open to the whole world, so everybody can apply. And so therefore, it is really the scientific excellence that is counting. And Europe has a full access to that, and we have a significant fraction of the time that we are expecting from the first cycle. So let's keep on going strong.
Did that answer your question, Fulvia? No, I think she still has some issues with her audio. I see there are plenty of questions coming in also on the launch campaign itself, the readiness of the payload. Maybe this one from Stephen Clark, I think could be one for you, Thomas. What's the latest status with the readiness of the payload fairing on Ariane 5?
So I think I'll leave the fairing question to the Ariane Space friends, but let me just talk to you about the payload quickly. We're continuing to make rapid progress. We're very much on track to basically start the kind of overall, moving the folded spacecraft into the container for shipping towards the end of August. Of course, we're because of the issues that we've already communicated, our transponder and so forth, we're kind of, we don't have a lot of reserve, which is, of course, at the end, we want to put it into the container with zero reserve, right? So kind of that's what the point is we're looking at. So basically, then once we're shipping, it's all the really, we want to ship when we're sure that all the boxes have been checked, everything has been checked and double checked of the spacecraft. But I'd like to turn it over to one of the Ariane Space colleagues to talk about the fairing and the rocket, which is the second part of the question.
Maybe Daniel?
Okay, so concerning the fairing, indeed, there were an anomaly which has been mentioned recently in the media. So the origin of the problem has been found, corrective actions have been taken, and the closure of the anomaly is close to completion. We are doing the last test these days. Qualification review has started, so we should be able to confirm all that within a few days, weeks. And this will not jeopardize in any way the launch of James Webb.
Thank you very much, Daniel. I see Peter de Selding from Space Intel. Peter, you have two questions as well. Is your microphone unmuted? Can you speak? Peter, can you hear us?
Hi, can you hear me now?
Yes.
Yes, we do.
Yes, all right. I have two questions for Thomas Jurberken. First, Mr. Jurberken, I understand you don't want to comment in details on the fairing issue, but I have just a question for you as the customer, and that is whether over the last 10 months or so, which is how long Ariane 5 has been down while struggling with this fairing issue, you feel like you've been given full transparency from either the contractor or Ariane Space and ESA on what the situation was, and at least to that extent, as a customer, you feel like you've been given all the information you need. And the second question is, if I understand Beatrix's presentation, where you've got a 10-week start from the time of shipment with 2 weeks overlapping, so assuming an end August shipment, this JWST won't really be ready until sometime in mid-November. Is that fair? Thanks.
So the first question relates to the interaction that we've had, and the answer to it is very simple: yes. We've had all the information that we need. We've had in-depth technical discussions, really with all parties aligned with one goal, and that is to create mission success here. We want to be sure that we launch exactly when we're ready, not a day earlier than we're ready. And that is that when the spacecraft is ready and when the rocket and the fairing and everything is ready. And that's, I feel we've been really aligned with all discussions with full transparency. Really want to thank, frankly, the both the European Space Agency, but also Arianespace for that enormous support we've had. Needless to say, we're in the business of rocket science, which we're used to problems. So the fact that there's no problem is not a state we ever get to. We always want to find the problem that we're most focused on. The second piece that you're talking about, which is the timing, yes, I think your assessment is approximately correct, right? It depends on the days that are there, but the assessment that you're outlining is correct. I don't really have anything else to add.
Thank you very much, Thomas. The next one is Sophie de Villiers. Sophie, can you hear us? Sophie, do you want to take the word? Then maybe I'm just going to read your question. So the question were, which exoplanets are Webb's targets for finding traces of life? Are the TRAPPIST planets discovered in 2017 among its targets? Yes, so I think this could probably be a question for Antonella.
Absolutely. So yes, I think that exoplanets will be covered by many different constituencies. The guaranteed time observers, who I think have claim to the TRAPPIST system, and then the general observer who competitively won time in the last peer review to look at their favorite targets. I can tell you that approximately 22-23% of the Webb time will be devoted to the study of exoplanets. So this will be a significant investment for this observatory.
Thank you very much, Antonella. Next one, I would like to give the word to Dirk Wagner from Radio HR Info. Dirk, can you hear us? Otherwise, I will read your question.
Yeah, hi everyone, and thank you for doing this. Yeah, my question is about the pictures we can expect from the JWST, because it has always been described as a sort of Hubble's successor. So what do you think we can expect from these pictures? Will they look like Hubble 2.0 or 4.0 or something like that, or more like pictures from other infrared telescopes we've seen in the past? Thank you.
Shall I take that, Nina? Happy to do. I believe I showed some pictures, side-to-side comparison between the deepest Hubble images and what we expect from James Webb. It's clear that James Webb will go further to the red, so the objects will be more distant because they are redshifted. But James Webb is about 100 times more sensitive than Hubble, so the images will be just looking much fuller, much denser. And then when you do the detailed comparison, because you have a 6.5 meter mirror compared to the 2 meter mirror, the images are also 3 times sharper. 3 times sharper is really very significant, because it means that the points are a factor of 10 less area and therefore much more sensitive. So I think James Webb images will blow our mind.
Do you mind, Günther, if I quickly go back to a specific question that was answered, that was asked earlier, and that was about TRAPPIST. And I just wanted to point out that, in fact, yes, TRAPPIST is one of the targets that has already been selected, as have been others. And I just want to say that in addition to TRAPPIST, there's a number of targets that are being analyzed right now, Günther, both by a spacecraft that you have in orbit right now. You may want to talk about this, but also the test spacecraft on our side, and continually we're going to want to identify the best exoplanets to go look at as we get to know this telescope better in space.
Yes, indeed, Thomas. I mean, TRAPPIST is a wonderful system. It is 7 Earth-like temperate planets, all inside the orbit of Mercury, close to its star. We have an exoplanet study mission in orbit currently, which is called CHAOPS, Characterizing Exoplanets. And that has discovered another system, which was actually originally found by TESS, and it has found another 6 planets, more or less in the kind of same configuration as TRAPPIST. these planets actually are in a so-called Laplace harmony, so they are singing together at a tune, and so they will be clearly among the golden exoplanets that James Webb will look at, and hopefully we will discover more while Webb is going on, because the ultimate holy grail is to find something, a temperate exoplanet that we could look at for life.
Thank you very much, Günther. The next question is from Marc-André Miseret. Marc, can you hear us?
Yes, I can hear you.
Welcome,
everybody. It's been mostly answered. Actually, you said Webb will dedicate 22% of its time to exploring, watching exoplanets. You mentioned TRAPPIST. You mentioned TOI 178, I guess.
Yes.
I just wanted to know, because we're always writing for national media. Are the Swiss very present in the requests you have already got, or maybe already accepted, for watching exoplanets?
Maybe I can take that. You know that the Swiss colleagues are very far. I mean, they are leading certain parts of that field. The Nobel Prize 2 years ago went to Didier Queloz and Michael Major, and they have also their specific ground-based facilities. So it's clear that they have a kind of and they're also partnering with us to the Cheops satellite. So in principle, yes, the Swiss colleagues are quite far, not ahead, but at the front of this research field. But the same is true for several very strong groups in the US. There's the California Planet group. My old institute in Hawaii is also very strongly engaged. So I believe this is a worldwide exercise.
Do you mind if I just give a specific number? And with my Swiss accent, it's probably okay to say that, Günther. And that's that the Swiss in this first round won 8 proposals as part of this. So there's 8 investigations in Switzerland, which is kind of indicating, of course, indicative of the leadership role that together with so many others Switzerland has in this field.
Thank you very much. Thank you, Thomas. Thank you, Günther. I see there are a few questions coming in on the launch date, if it is confirmed. So I would like to give this question to you, Beatrice.
Yes, okay. So for the launch date, we have a combination of different factors. One is the payload readiness, but we have also the launch vehicle preparation activities and other possible factors that comes from the preparation of the spaceport itself. So we are currently consolidating all of those information for the definition of the launch date for the next Ariane 5 launch. And as usual, we communicate the date only a few weeks before the launch. For James Webb, it will be not earlier than the 31st of October, but we have an agreed launch period that spans up to early December. So while we are working on performing all the activities to consolidate the launch date, and then we will identify that at a later stage.
Thank you very much, Beatrice. There are 2 quite practical questions as well. The first one is, when can we expect Webb to be fully working, and when does the general public will actually get the first images? So maybe a question to you, Günther, or to you, Antonella.
I think, Thomas, that is for you.
Oh, so let me just tell you why this is a hard question to answer, and I just want to explain to you why. So suppose we're launching, everything goes exactly like we hoped. We're launching on a given date, and we go up there and we start our kind of journey to Lagrange point 2, which you just outlined earlier. And so basically we're going there, and basically what we're going to do as we launch, and in the first few days, is we're going to start unfold like this transformer, right? That you've seen that children's toy, like unfold the various things, right? Of course, the solar panels, because we want to charge the batteries, the antennas, and then these tennis court size thing, and and so that basically takes several weeks, right? For us to do that. The fastest this could be is like of the order. Think of it like 20 to 30 days, kind of assuming everything goes well. Now, we're not done yet, right? Because now we have kind of the machine set up, but now we need to fine tune it. And what needs to happen now is that we actually both set at the mirror, kind of with these small, you know, with the controls that each one of those segments has, kind of set the mirror as one. So it actually works exactly as a single platform. In the meantime, as we're going out, we slowly cool down the telescope. And so basically, when everything is said and done, kind of, we will have, if you want, the highest resolution kind of image months later. So it's really is several months after we do this. So kind of as we're going to go, I think what we're going to try to figure out is where along the journey can we give some pictures that are not at the highest resolution, but think of it like 4 to 5 months or so, or even 6 months, depending on how it all goes. That kind of really we will have the highest resolution picture. So this is very different than, let's take an Earth observer in which we launch and within days we have the first data and have the pictures ready. So it's what we're going to do, and together with our international partners, is have a really transparent communication. So you will know along the way where we are on that journey to that unique and history-making first image at the highest resolution this telescope will provide.
Thank you very much, Thomas. And with this, I would like to give the word to
Nina. Excuse me for interrupting what I just did. You all have watched the 7 minutes of terror for the launch, for the landing of Perseverance. This, as Thomas says, will be 20 to 30 days of terror. So we will not sleep very well at that time.
Thank you, Günther, for this add-on. With this, I would like to give the word to Jennifer Myriad, if I pronounce that correctly. Can you hear us, Jennifer?
Yes, I can hear you. Can you hear me?
Very well, thank you.
Thank you for taking my question. So it's a two-parter, really. I was just wondering, because the James Webb Space Telescope is an infrared telescope and so it requires cooling, what's the expected lifetime of the instruments? And is it going to be able to operate in some form for an extremely long time like Hubble? And is it possible that Hubble will outlive JWST?
We should take that.
So we all hope that Hubble lives forever, right? And it's just like what's really hard is actually, I mean, these are simple questions to ask and hard to answer. And then I just want to tell you, like, I built some instruments. The first instrument I built, actually, before I even came to the US, was an instrument that had a lifetime of 2 years. And I've been in the US for over 25 years, and the instrument is still working, right? So that can happen in the case of Hubble. Basically, in the case of Hubble, where it's kind of getting kind of long in the tooth. Kind of, it's a little bit, we have some age issues, and the team has been just doing a fabulous job, the international team, of continuing to utilize it. But the lifetime of Webb, governed by fuel primarily, is 10-year minimum. So I think it'll be, even with the best of all hopes, I don't think Hubble with all this will last another 10 years based on kind of where we are. But I would be so excited to be surprised. We say 10-year minimum because that's what we've done. But you should know that generally speaking, we're really good once the telescopes are up there to really save fuel and learn how to do this and kind of extend the lifetime of these issues. So basically, let's see. I want to just quickly go back and just basically say the first high resolution image that we're expecting, assuming everything goes exactly like when I spoke to all of the instruments and so forth, will be 2 months or so. So kind of, you don't have to wait 6 months for the first one, but the 2 months is enough. So basically, of course, 6 months for the entire suite.
Thomas, maybe just in addition, because the lady was asking about cooling. I mean, the fact that we have this wonderful sun shield, the tennis court size sun shield, means that we are looking into the deep space and we are shielded from the heat from the sun. So we don't need we don't need additional active cooling like other infrared space telescopes, and therefore there are no consumables for cooling. The consumable is mainly the station keeping fuel that Thomas mentioned.
Thank you, Gunther.
Just, Nina, I wanted just to add something to what Thomas said and Gunther about Hubble and Webb. I think our hope is that Hubble and Webb will be working together for several years. It's, from a scientific point of view, is really powerful to cover the entire range from the ultraviolet to the mid-infrared. And astronomers are already using that synergy, and we hope that synergy will go on for as long as it's possible.
I agree with you, Antonella, very much so.
Thank you very much. Stephen Clark, I see you had a few more questions on Ariane 5 and the fairing. Do you still want to address them? Can you hear us?
That's loud and clear. I just wanted to follow up with my question earlier about the Ariane 5 fairing. The anomaly that was observed, I think, on the most recent Ariane 5 launch last August. Haven't heard many details about that. I know that fairing had some new venting ports designed for JWST. What was the issue that was observed, and are there any, what are the corrective actions going forward for these next two Ariane 5 fairings before JWST? Thanks.
Okay, so I think I should reply. So first, the issue of the modification of the venting system and the fairing anomaly are different. They are not issues. The venting adaptation of the venting system for James Webb is really specific for James Webb. The fairing anomaly has been met twice in last year, and the root cause has been identified and action have been corrected. So it's relatively minor when you see the design of the fairing, but it has to be done in order to be fully successful.
Do you mind if I just...
The anomaly has occurred during the separation of the fairing.
Thomas, why don't you join in?
So I wanted to just talk about the venting ports quickly, just so everybody understands what that is. That has nothing to do, as Daniel just talked about an anomaly. And so basically, when you build a complex spacecraft like Webb, and you look at the spacecraft, you immediately, especially if you see it in a room, you kind of, your heartbeat goes up a little bit because you see it's kind of a flimsy kind of, especially these shields are really kind of not like stiff and stable like so many of the spacecraft that we build, which have entirely different purpose. They're designed exactly the right way. But one of the critical elements is to make sure that after launch, as the air streams out of the fairing, the release of the pressure, kind of the reduction of pressure over time, and especially at the release, is such that it basically all the, if you want, the air force on the force of the air on the spacecraft on all phases of that is within limits that were tested. And so of course that means that in some cases we stiffen things on the spacecraft. In some other cases, working with Arianespace and their contractors, we basically built venting ports to make sure that we're really doing this the right way. So again, this is another great example of the excellent collaboration that we've had between the various parties.
Thank you very much all. The next question is from Daniel Reguera. Daniel, can you hear us?
Hola, hey Ninja, how you doing? The question is regarding the telescope like the Hubble. do we have the opportunity to repair at Lagrange 2 this telescope like we did with the Hubble telescope?
So the answer is very simple, and the answer is no. The answer is no. So basically, there are really two reasons for that. The first one is, Hubble was from the beginning laid out, kind of every electronics board, kind of how the instruments were done, was laid out for repair and for servicing, right? Webb, because of its very low temperature and because of its location much farther away, right, down at the L2 point, which is 1.5 million kilometers, right, kind of away from the sun, much farther than the moon, for example. That was just, it was not laid out that way. Frankly, we do not have the ability of fixing it. That's why it's so important that we do all the tests and all the analysis, whether it's focused on the spacecraft or the rocket, with the due diligence that we are, in which we really assure that this thing will work once we put it into space.
Thank you very much, Thomas. There are some questions on the financial contributions, also from the Canadian Space Agency. So I would like to give the word to Marcia Dunn. Can you hear us?
Yes, can you hear me?
Very well, thank you.
Yes, I understand that the U.S.'s cost for the Webb is about $9.7 billion. And could I have an approximate figure from both ESA and the Canadian Space Agency so I can understand total how much is being invested in Webb? Thank you.
Maybe I can start with the ESA side. So the contribution to James Webb from the very beginning was one of the ESA M-class missions. We have large missions that cost roughly $1 billion or so. We have the medium-sized missions, which cost roughly $500 million. But in all of the ESA missions, we always have a very strong cooperation between ESA on one hand and the member states. So the member states are contributing to the payload, to the instrument. And so therefore, it is very hard to basically calculate an exactly comparable amount, because in some cases, for instance, institutions are involved there's not a full cost accounting. But you can say it's roughly of the size of an M-class mission, so on the order between 700 million or up.
In the case of the Canadian Space Agency, total investment right from the beginning, 20 years ago up till now. So that includes developing the hardware, the instruments, supporting science, maintaining an engineering team. It's around $200 million Canadian, which is, considering the total cost of the mission, it is an impressive feat that we were able to achieve and deliver 2 instruments for that kind of money. But consider that this is an investment in discoveries of the universe. This is, and I would just say it's astronomy. I think after the astronauts, I haven't seen the latest statistics. Astronomy pictures are the single most important and most interesting and attractive imagery of space. So, and I'm not even talking about the science. The new chapters in astronomy and astrophysics that we will be able to rewrite in the next few years. So $200 million Canadian again.
Thank you very much, Gilles. Thank you very much, Günther. We have another question from Irene Klotz for Ariane Space. Irene, can you hear us? Irene, can you speak? Then let me read the question. Has Arianespace ever launched to L2? And what are the challenges of the higher energy launch? Beatrice.
Yes, we have already launched to L2 because we had as well the other scientific missions from ESA. For the energy, maybe go pass the question to Daniel, who will maybe learn more about that. But what we can say is that the trajectory is an injection orbit with an apogee of about 1 million kilometers. So we have all the performance of the Ariane 5 to achieve this orbit for the mass of the observatory that is a little bit above 6 tons.
Daniel, would you like?
No, I can just confirm that indeed we have plenty of margin for the performance. So it's absolutely no issue to launch this Webb with a mass of slightly above 6 tons.
Thank you very much to both of you. I see we are getting close to the end of this media briefing. There is a question on how long the scientific program is already planned and how we manage the choices, so the scientific choices. Maybe a question to Thomas or to Antonella?
Antonella, I think, is deeply embedded in this, so maybe if you can.
Yes. So Webb observing time is distributed through a peer review system. So we invite many representatives from the worldwide US and European community to assess the proposals that have been submitted. And a program is crafted and presented to the director and to the NASA project scientists to decide what will be observed during the first cycle, which is typically starting 6 months after commissioning, after launch, and then will extend for a year or so. So that first year and a half is already being planned. It has a portfolio of observation. We cover all aspects of astrophysics. So as I said earlier, expect a lot of discoveries coming from that, from the early release science, and from the guaranteed time observations. The 3 groups will basically fill the schedule for a year or so, and it will be just amazing.
And then it will be done in yearly intervals, right? So every year you have another chance to adapt.
Every year there will be a call will be issued. Astronomers will propose their best ideas, and a review of their peers will evaluate which one will make it to the telescope. So it's a very democratic process, and it produces fantastic results, as we've seen with Hubble for 30 or so years.
Thank you very much, Antonella. And the last question comes from Dirk Wagner. Dirk, can you hear us?
Yeah, thank you very much for taking my question. I've just wondered, because in some Hollywood movies we see Hubble Space Telescope pointed rapidly at some object in the sky that suddenly appears. We all know that's not possible with the technology up there, and that's not the intention, because every observation is planned in advance. But I wonder if there's a sudden event in the sky in a specific region, how fast would JWST be able to point its instruments there? And is there some kind of rapid pointing mode just for this? Thank you.
So
I can attend to. Okay, go ahead, Tom.
Go ahead, Antonella, please.
So there is a category of observations that is called target of opportunities. And so they are triggered by some event that is transient. And so once that target of opportunity is accepted, has been accepted by the peer review we were talking about, when that event is activated, it will happen pretty quickly. I cannot give you the number of hours required, but it will be pretty quick.
So I think what I would add to this, exactly, you're right, Antonella. So let me just add, I think it, depending on where you are and how far away it is, it may be a day or 2 or a few days, you know, depending of how you need to reset up the telescope again. I think what really is important for everybody to understand is how complex the setup is, both from the mirror side, but also how really all the instruments are set up. For a given observation to be meaningful, it would have to be set up. And so depending on the changes, you know, it will take more or a longer or shorter time. But I think it's really important, Antonella, like just like you said, that we have that responsive mode, because so often the sky surprises us, right? Kind of something really amazing happens, you know. And of course, I'm hoping for this kind of other kind of extra solar system asteroid that's coming back in, like Oumuamua or something like that, where we'd really like to look at with better eyes.
Absolutely.
Thank you very much. Thank you. A big thank you to all the speakers today. This brings us to the end of this press briefing on James Webb. There will be many to follow over the coming months and years, I am sure. I also want to thank all the participants and all the journalists that were here with us today. There will be, of course, the opportunity to ask many more questions, and there will also be a recording available of this press briefing. So thank you very much. Thank you all, and have a nice day. Thank you.